Okay. If you can hear me, please give me a thumbs up. Give me a thumbs up. Can you hear me? Thank you very much for joining. So I want to welcome everyone, especially to the day 2 of this professional training, industrial machinery maintenance. The industrial machinery maintenance actually covers 4 aspects of maintenance. That's the electrical maintenance, the mechanical maintenance, the control system and automation maintenance, and the pneumatic and hydraulic maintenance. So the industrial machinery maintenance training that we are having for a span of 3 days actually covers these 4 areas of our maintenance. So I want to welcome everyone, especially to the day 2 of this training, the class 2. Those who were here with us yesterday actually had a wonderful time and a very great atmosphere of learning we had yesterday. So I want to congratulate you all. And today's class actually promises to be very, very interesting and detailed. And you are not going to regret about joining this training. I want to say welcome to you all. Again, my name is Kehinde Samson Ogumiwa, and I'm going to be your moderator for this training session. So this training is brought to you by COC Concepts Training Company Limited. This is a professional training firm, been in existence for a couple of years, 10 years or more. And we have been in the field of trainings that cut across all industries across board, maybe it's engineering, finance industry, manufacturing industry, even entrepreneurship and the likes, the business industry. Our training actually cuts across board. So we have a series of trainings. So for more information about the trainings that we offer, you can visit our website on www.cocconcepts.com. So trainings are very much more spelled out on our website. So I want to encourage you to take your time to, try to research more about us and try to see how you can align and do business with us. I want to say welcome to you all once again for joining us. The training yesterday, we started on industrial machinery maintenance, and a whole lot was discussed concerning maintenance. And I think we stopped the metrics that are being used when it comes to maintenance. So we are going to be picking up from where we stopped yesterday. I want to appreciate our resource person, the person of Mr. James Pani, who has been very, very resourceful in the facilitation of this training. I want to say thank you very much. And he's here with us already. And the next minute from now, you are going to be hearing the voice of our resource person. Do we have anyone who didn't join us in yesterday's class? Is there anyone that is here with me now, currently in this class, that wasn't present in yesterday's class? Anyone? Just signify. Give me a thumbs up. Okay. Look more Lati. Okay. Is there any other person that wasn't here with us in yesterday's class? Any other person? Okay. So if you couldn't, for any reason, be a part of yesterday's class, you have the opportunity to rewatch the recorded video. So like I did say, I dropped the YouTube link, our YouTube channel link. So you have to follow the YouTube channel, subscribe to the YouTube channel, so you'll be able to have access to the recorded class from yesterday. So it's even easy, and it's very, very encouraged that you do that. Even if you are part of yesterday's class, you still have the time to rewatch, the class from yesterday. Just go to our YouTube channel, subscribe, then you'll be able to watch the recorded video for last class. And for the sake of your assessment that is going to be coming up, it is even very, very beneficial to you if you have the link to the recorded class. So that being said, every of our classes are recorded and we are dropping them on the YouTube platform. So if you have not subscribed to our YouTube page, I'll be dropping the YouTube link in the in-message session. So please do subscribe so you can you can get ample updates in due time whenever we drop any of our videos or upcoming training sessions. Okay, so having said that, information regarding the certification for this training is going to be dropped on the WhatsApp group. The certificate documents is going to be dropped so you can have a preview of it. Once the class is over, we are going to be dropping it. So you be able to read up on the certification and what you need to do in order to get the certification. Trust me, the fee for the certification is at a discounted rate, and trust me, you don't want to miss this wonderful opportunity that we are giving out. So once again, I say welcome to you all. We are going to be diving in straight to today's class. So please, if you can see my screen, just give me a thumbs up. Okay, let me bring this down first so you can rejoin once I, just a minute, please. Okay, so if you can see my screen, just give me a thumbs up if you can see my screen. Okay, thank you very much. Thank you very much. And if my voice is audible enough, just give me a thumbs up as well. Okay, that's great. Thank you so much. Okay, so the next voice you'll be hearing will be that of our resource person, Mr. James Fanny. At the end of the class, please take notes of your questions. We love to encourage you asking questions. It shows that, yes, you are attentive while the class is ongoing. So please take notes of your questions. At the end of the class, we'll take your questions and we'll respond to it. If you have any practical situations around you that you want to discuss, feel free to bring it up at the end of the class. We are much willing to share our knowledge and understanding with you. Okay, so the next voice you'll be hearing will be that of our resource person, Mr. James Fanny.
Yesterday we started can you hear me and can you see my screen? Just give me thumbs up. If you can hear me, you can see my screen. Just give me thumbs up. Okay. Okay, I see. All right, thank you very much. So yesterday we started the course, industrial machinery maintenance, and we dived into maintenance as being, activities that we carry out on machines in order to put them in a good shape. So I explained why we need to, perform maintenance for the sake of reliability of our machines, and that these machines, they should be treated exactly as we also have, senses of organs, that, your sensors on your machine, they have what they are communicating to you. When the temperature is, is high, it has something that is communicating to you about your machine. And by, putting maintenance, into our culture across every industry can actually elongate the lifespan of a machine, can secure our own safety as personnel that is working on the machine. It can also give us a good reliability so that the production of the company also will not be affected. So yesterday also we discussed that what it costs, to perform maintenance is very negligible, or let me say, it's just a percentage of, what it may cost you to replace a machine or to deal with a downtime. So in other words, it pays for us to maintain machines than for them to actually fail. Okay, because when they fail, that you may not guarantee, depending on on what caused the failure, you may not guarantee the uptime. So the downtime, might actually linger than you expected. But when we perform necessary maintenance on the machine, it's guaranteed reliability. So I ended yesterday's class with, we discussed a whole lot. Yeah, that yesterday, but I'm just trying to give you, I still appreciate our moderator. I think he dropped the recording of yesterday's class. So I promised you yesterday that we would look into MTBF, that's mean time between failures, mean time to repair, okay, and also I discussed one yesterday, mean time to failure. So let me share the screen from this other device. And then We will look into this calculation very briefly. I think I still have the page. Okay. So we'll look into this calculation together. So I really want you to please give me your undivided attention in order to really get this calculation once and for all. So I'm going to be using some illustration. I explained yesterday, you know, some people will say they will call this mean time. You can see it as mean time between failure or before failure. Okay, so I choose to call it mean time before failure. So let's first deal with what mean time, okay, before failure. Okay, mean time before failure. So let's say we have a machine, okay, that runs from, you know, they run this machine, the uptime of this machine is actually 10 hours. So I'm going to write that uptime equals to 10 hours. So the company actually proposed to run this machine for 10 hours. Okay. And let's say within that 10 hours, we have some failure that occur. Let's say failure. And let's say this is downtime. So the first failure occur, and we have another failure that also occur here. So this failure that occur here lasted for 2 hours. That's the downtime. And the failure that happens here lasted for 1 hour. So from this, we can easily see that our total operation time. So total operation time will definitely be that. Yes, our uptime, or let me say our proposed production time, okay, let's use that so that it will not mislead us. Our operation time. So this is the operation time. The company actually wants to run this. They need this machine to run for 10 hours. Okay. But right now they have about 2 downtime, which is 2 failure. Okay. And this 2 failure actually one lasted for 2 hours, the other one lasted for 1 hour. So our total operation time, which is TOT, will definitely be our operation time that we actually propose to run the machine minus the downtime. So this is no calculation. What we're actually discussing is that there is a company that they have a machine, and this machine is actually scheduled for an operation, for a 10 hours operation. So this is when they need the machine. They need it to run for 10 hours. But during these 10 hours, it happened that there are 2 failures. Okay? There are 2 failures that actually occur during this particular time that the machine is supposed to operate. And one of them lasted for 2 hours. That's cool. Yeah, it's cool. Please pardon me. Sorry. Pardon me, sorry. So this failure, the first failure lasted for 2 hours. The second failure actually lasted for 1 hour. So if you want to look at how many hours, that's total operation time total availability time that the machine has operated now will be the 10 hours that we needed the machine minus the total downtime, which is 2 plus 1. That's 10 minus this. That gives us what? 7 hours. Now, 7 hours, the machine has actually what? Successfully run for what? 7 hours. Now, we want to know the mean time before failure. Don't forget, anytime we are talking about mean, we are talking about average. So what is the average time that the machine actually runs before it fails? That's the interpretation of mean time before failure. Let me take that interpretation again. What is the average time that the machine actually run before it fails? What is the average time that this machine runs before it fails? That will be the total operation time, which is TOT, divided by number of failure that is recorded. And if you are going by this calculation now, that will be 7 hours, which is what? Total operation time, divided by number of failure. How many failure do we have here? 1, 2. Just 2 failure. And that will give us 3.5 hours. What does that mean? By this calculation, this is how company actually predicts, the reliability, or this is how they actually calculate the reliability of every machine. Every manufacturer also do this. And sometimes when you are talking about industrial machine, we care so much about MTBF. But if you are talking about maybe consumers' goods or consumers' machines, most of our domestic machines, most of us don't really look at what MTBF. We don't really care. Because we don't need them to run for a long time, okay? Or we are just looking at what the low cost of that particular machine. But every company wants to actually know for how long can this my machine sustain me. So you can imagine what is the interpretation of this now. It means that this machine will always fail at every 3.5 hours. Once this machine runs for 3.5 hours, it will fail. That's what MTBF that we have calculated actually means. So it means that the reliability of this machine is based on 3.5 hours. That is, this machine, when you power it on, when it runs for 3.5 hours, it will just go off. It will fail. So we are using hours to calculate this. So in case if the hours is now much and then we run it into days, that's when you see, the company will now say, okay, fine, we have known that this machine will fail for 3.5 hours. Don't forget yesterday, every 3.5 hours, this machine will go off. Then we go to preventive maintenance. So on this machine now, we explained yesterday that preventive maintenance is a scheduled maintenance. So because we have known that this machine, every 3.5 hours, it will go off. And mind you, we needed this machine to run for 10 hours. In order for us, if we don't have a better machine to replace this machine with, we can now say that every 3 hours, the machine must be shut down for maintenance. So you see that. So that, we have already set the preventive maintenance schedule to be just before the time that the machine will fail. And that would make us to, if we are the one that shut down the machine on our own, perhaps we check what is making this machine to go off. Maybe we have already know that maybe the oil level always go below the normal. Then we stop the oil. We clean, maybe there is dust that would have been covering a particular contact or anything. We clean it, and then we start our machine. Then we are sure that the machine will still run for another 3.5 hours. So before it runs for that 3.5 hours, in the next 3 hours again, we shut it down. In some company, you see some machines that their own is 3 days. Okay, they shut it down. And even I have people here that, maybe you are in charge of some maintenance in your company, or you are familiar with some machines that they have, you are familiar with the time that they normally shut them down for maintenance. I would have loved those people to share their experience. So there are some machines that they shut down 3 hours, 3 days, every 3 days, every 4 days. But how do they know that this one should be shut down after 3 days? How would they know that this one should be shut down after 7 days? That's because there has been calculation on MTBF, which is mean time before failure. What is the average time that the machine will run before it fails? So every machine. So what happens when you see a machine with low MTBF? For example, if you see a machine that have MTBF of 3 days, and you see a machine that have MTBF of 7 days, which of them is a better machine? So that's the question I'm asking. If a moderator is there, the moderator is not there, no problem. Just raise your hand.
I'm here with you. I'm here with you.
Okay. Anybody that wants to answer that question? If with MTBF of 3 days and a machine of MTBF of 7 days, which one is better and why?
Okay, do we have anyone who wants to attempt that? Okay, Alao Abdurazak. Alao Abdurazak, you can unmute your mic.
Okay. Good morning, engineers.
Good morning. So respond to the question, sir.
I think the one of 3 days is still okay than the one of the 7 days of maintenance, sir.
Why is that?
Because the one of 3 days, like when you are doing the preventive maintenance 3 times and 3 days, of which compared to the one of 7 days that you have longer downtime on the machine. So I guess that is the reason for my own answer.
Okay, thank you very much for your response. Let's continue listening. Do we have any other person that has a contrary response? Lukman Latif. Lukman Latif, I saw your hand.
Yeah, can I speak? Can you hear me?
You are not audible enough. Can you speak louder?
Hello. Good morning. Can you hear me?
Okay, please go ahead.
All right. I would suggest sometimes you should check the sections too, so that we will not be interrupting with our voice. But based on the question, my own response is MTBF of 7 days. Because for a machine to run 7 days before needing maintenance, it is better than a machine that would run 3 days and would need maintenance.
Okay, thank you very much for your response. Okay, let's continue with our class.
Ezekiel Akwan, are you there? I can see your hand. Ezekiel Akwan. Ezekiel Akwan, can you hear me? Okay, Fawaz Lawal.
Can you hear me? Ezekiel is up now.
Okay, Ezekiel, you can respond to the question.
Yes. Yeah, more time before failure of 7 days gives us a better availability compared to maintenance before failure for 3 days. So it's a better machine. The second one is a better machine.
God bless you. So now we understand this now. I'm very, very confident that we understand this. So the one with MTBF of 7 days, it means that has a higher reliability. And this is how you can even choose which kind of, you can have maybe different manufacturers of a particular machine that is doing the same thing. So you have tested these products, with the MTBF. You have tested this product with the MTBF. So you know that this will actually be much more reliable. We don't just say the machine is much more reliable by just looking at it. It is by putting it to test and calculating the mean time before we run it to failure. We see how well it can actually run. Before we determine MTBF, we have to first run that machine and see when will it shut down. We'll perform we'll bring it up again. We'll run it again. We see when it will shut down. And then this is, we see how long the first downtime, how long did it take us? The second downtime, how long did it take us? And then we use this to calculate our MTBF, and then we know the reliability. So that's about what MTBF of a machine. So let's talk about MTTR, which is mean time to repair. And I actually explained this yesterday a bit. I think I explained this one a bit. Let's say that, let me give us an illustration. Let's say we have a company that they run for their operation within a week is 40 hours. Okay. And they run for 40 hours. This is their TOT. Total operation time is 40 hours. And then within these 40 hours, they had 4 failures or 4 issues. Let me use the four issues. Don't let's call it failure. 4 incidents actually happened, which actually means what? Downtime, or 4 downtime. So this is their total operation time. That's for 1 week. They were off for 40 hours. Okay. And then they recorded 4 downtime. But the total time it takes them to resolve these 4 failures, last 1, that's the first failure 1, failure 2, failure 3, failure 4. The total time it took them to resolve this failure is actually what? 1 hour. When they calculated it, that, oh, we recorded 4 failures. So how long did it take them to bring it up the first time, second time, third time, fourth time? So they had all the time together, and then they see that, okay, it's actually 1 hour. They use 1 hour to bring to resolve the 4 failures that they recorded. So how do we know our MTTR? That's mean time to repair. Don't forget mean. Mean, of course, we remember what mean is. But I say find the mean of 1, 2, 3, 4, 5. I hope all of us are familiar with that. We had everything together. Okay. And then we divide by the number of this number, which is what? 5 numbers. That's 5, and that will give us what? 3. Okay, that's what mean actually mean, and that's what we are doing. So we want to find the mean time it will take us to always respond to failure, or to always bring up a machine that actually fail. So if we are to do this, 1 hour is actually the time. And the number of failure recorded is actually 4. So we can convert this to a minute, which will give us 60 minutes divided by 4. And that will be 15 minutes. That means that our MTTR is actually 15 minutes. So in other words, if we are going to interpret this, MTTR let us know the responsiveness of our maintenance team. How long does it normally take them to resolve a problem? When you want to get contracts from a particular company, like I've worked with a company before, I won't mention name. Many of us that have worked in telecommunication industry, we know that all these telecom industry like MTN, Glo, Exalat, they do not, before when they started, they normally employed the site engineers themselves. Those are the site engineers that manage all these, or that maintain all these their masts, all these their sites. So they used to employ them in those days. But later on, they wanted to do away with that load, that stress. So they started giving contracts to some, maintenance company. That way, they can sign a contract of 5 years, 10 years. So they are going to be on maintenance of all their sites. And there's always what deal with them. That what are the allowable or the tolerance time for a particular site to actually go down. What is the tolerance time? It is when this company actually default with the tolerance time, definitely in their calculation of remitting the money to them is going to actually affect that company. So the company I work for was a company that actually got these contracts. Okay, many of us may who have the idea of telecom will actually know what I'm talking about, because in every mast you have the electronics guy and you have the power guy. There are some people that the engineer is just in charge of the power. So it's the one that you will be seeing that will be coming to site to check the diesel level, to maintain the diesel generator and all that. Those are the power guys. The electronics guy, they are the one that will be opening those all those transmitters, checking them. If the programming has corrupted, they will delete the one that is there, upload a new one or update. So you see them bringing laptops to troubleshoot. If you have seen them around you, you will know what I'm actually talking about. So I actually worked in the power sector of it. So one of the things that they care so much about, that's where I'm going, is the MTTR. That is the responsiveness of your team. We don't say that there will not be downtime. Of course, downtime will always happen. Like we explained yesterday, maintenance are of different types. If it is not preventive, it can be corrective. And in most cases, it is not that you do not perform the preventive maintenance. In most cases, or let me say in few cases, there are few occurrences like that it's not just because you did not do a good preventive maintenance, but something may happen that the machine will just fail, and you have to repair it. It might be a major failure. It might even be the part of it that you never even touched during the maintenance. So anything can happen that can make a machine to fail, whether you perform a good preventive maintenance or not. We're just saying that good preventive maintenance will always reduce the occurrences of such failure. If you perform the maintenance very well, yes, it's okay. We have people like I had a funny story of a man who cares so much about his health, and because of that, he normally take all these Eva water. I'm sorry to mention the product Eva water. We know that it's a very clean, water. So it is not the Eva that is using, but I want us to pay attention to what I'm trying to bring out from there. So he was actually taking clean, source of water that, of course, many of us know that if you go to hospital, if you want to use drugs and you carry Eva water that you want to use to take drugs, you are considered to be safe. It means that the water is very, very clean. But for this man, despite taking clean water and all that, you can imagine somebody, if you want to eat, if this is the water that he drinks and everything, it was not even tampering with such a water. No matter how pure you think that is, or you advertise it to him. But he fell sick along the line and he went to hospital. And when they diagnosed him, they said that he had typhoid. The man was surprised. He told them, I take clean water. He said, you have typhoid. That's why you now began to have the orientation that typhoid does not really mean that it does not have to do with water alone. What about the food that you eat? You can eat any contaminated fruit and all that. So the educated in that say, okay, so if I can actually contaminate, if I can be down with the typhoid, despite the fact that I care so much about the kind of water that I drink, and from that day, there is no kind of water that you give this man that he would not drink. Bring pure water, bring anything. After all, he has taken clean one before. He said I should just be taking any water now. If after all, I'm not actually safe. So what am I saying in essence? You can do every preventive maintenance on your body. That doesn't mean that if you want to fall sick, you will still not fall sick. There might be anything that can trigger sickness. And likewise on machine too, you can do all the preventive maintenance. It is still possible. The percentage may be very small, but yet a machine may still fail. So there will be need for us to have a good responsive team. And this is what qualifies you as a maintenance person. It is not just it is not enough for you to know what to do. But for you to do what you have to do very fast and very quick, such that what you will be able to actually what reduce the downtime. In those days that I work in such an industry, you will have a walkie-talkie attached to you if you are a maintenance guy. Even if you are in operation also, you have a walkie-talkie, and you will be communicating 24/7 what you are working on. What's the progress of what you are doing? When do you think that? That's the question they will be asking you. When do you think that this machine will be up? When I was working in that telecom industry, they will call you at night. Your support engineer, because I was the senior field engineer, my support engineer might be, because I briefed him about everything, I carried him along. He will be briefing that they will say that no, they don't want to hear him. That I should go and wake me up. I must be the one to actually give that report. Because what everybody, all those, superior to you, what they are after is that what they want to reduce what the downtime. Because that's where what they lose money. In production industry, in manufacturing industry, every 1 minute, every 2 minutes, even every seconds that make up a minute can't. I don't want to mention him. The company where I work in Kogi State, some of us may connect from the training of yesterday. I think I mentioned him. They did calculation for us to know what the company will lose if a unit is actually shut down for 1 second. The money was not calculated in 1 hour. I want you to listen to me. They had to do the calculation of the millions of money that is lost if we are to record what a downtime of 1 second. So you can imagine, there are many people that have been sacked in company due to downtime. So your responsiveness, MTTR has to do with what? The responsiveness of the maintenance team. How fast can you actually what? Bring up a machine? Okay? And if the preventive maintenance is actually what? Very, very good. Trust me, it will be easy to bring up a machine. It will be very, very bad that when the machine actually fails, when they check it, they see that it is the oil level. It means that the maintenance guy have not done anything. But when the machine actually go down, it should be a major fault. It shouldn't be that what the oil level has gone down, there's no water maybe in the radiator, there's no this, all those normal things should actually be done, just like your car. You can do everything, take it for checkup and everything, and the car may still develop faults. But that shouldn't be because you did not do the maintenance. The maintenance has to be done, which is the preventive maintenance. So enough of that on MTTR. So what it means is that what the MTTR of this machine, this particular machine, how long does it normally take our team to bring it up anytime it would fail? Our team brings it up within 15 minutes. It means that they understand the machine. It means that definitely perhaps they carry out a good preventive maintenance on this machine. If you poorly maintain this kind of machine, trust me, the MTTR may increase to 2 hours. Because by the time the fault happens, it will always be a major fault. When the temperature is high, the machine is supposed to shut down. The machine is not shut down. It continues to run and run and run. And by the time the machine actually was shut down, definitely the high temperature must have spoiled and damaged so many things inside the machine. And there will be a whole lot of work for you to actually bring it up. So that's MTTR. Let's take the third one, which is MTTF, mean time to failure. Mean time to failure. Mean time to failure. Okay, mean time to failure is normally used to calculate the lifespan of a machine. Okay, if you check your car, the speedometer of your car, it will be showing you, how many kilometers this, how many kilometers has your car actually traveled ever since it has been commissioned as a car. So you'll be seeing it there. So we use these to know a better product. For example, this product is being made by this company another product by this company. Both of them are serving the same purpose. Let's use example of what? Bulb. This is a bulb made by what? Company A. This is bulb made by company B. We want to know which of them are we to buy that really have a longer lifetime. If we have to calculate their mean time to failure, then we'll be able to know a better one. And what do they do in this case? We are going to take the sample, 4 samples of A. If you want to get an accurate result, of course, you should use more than 4 samples. But we'll get 4 samples of A. And we power them up. Okay? Power what? The 4 bulbs, which are what? Made by what? Company what? A. Let's say this one blow out. This bulb actually blew out, after 10 hours. This one blew out after 8 hours. This one, let's say 9 hours or thereabouts. Okay. And let's say this one 3 hours. So we want to know the mean time to failure. So we then have 10 plus 8 plus 9 plus 3. Should we use 3 or let's just use 9 still? Okay, 9 divided by 4. So if you calculate this will give us 36 divided by 4, and then that will give us 9 hours. So it means that whenever we are purchasing this bulb, we have a level of confidence that the bulb will spend only 9 hours and then it's going to blow up. So the lifespan of this bulb is actually 9 hours. The mean time to failure of this bulb is actually 9 hours. Let's say we now see another bulb. By the time we calculate for bulb B, we calculate the entity F of bulb B. We do the same thing, the same way we get the sample here, and this one now gave us in 15 hours. What does that mean? If you have to buy, as an engineer, if you have to buy any of these of this bulb, which one will you go for? Is it the company A or company B? Anybody, just raise your hand. Let me see who is following us. Which one will you purchase? Is it the company A or company B?
Okay, Akawe Jude. Akawe Jude, you can unmute your mic.
Yeah, can you hear me? Good morning.
Yes, please go ahead.
Yeah, I'll go for company B.
Okay. Why are you going for B?
Because it has more lifespan than company B. But
Okay, thank
company
you. A. Okay, thank you. Boyisola Giwa, you have any alternative response? Boyisola Giwa.
No, I don't have alternative response.
Okay, thank you very much. Let's move on.
Anybody? Moderator, are you there? Mr. Moderator, are you there?
I am here. About Akwan. You can unmute. I'll buy one of a company B. Because the mean time to failure is 15 hours. Why the mean time for company B is 9 hours?
What does that mean?
So it means that the average time for people can fail is higher than the average time for A to fail. So I think I will have more time to use the word B than at the time I use this word B.
Thank you so much. So this is how you see that, you will see that why do they like this product? Is this product, it's not just by mistake. It's something that you can also try. These are experiments, okay, that people actually do. They intentionally find a study, if it is a bulb you are using. I'm just using a bulb for example. It might be a different kind of machine. You just want to know how long it will actually what take before this machine actually what pack up. So you see some companies that normally do new editions of their product, like they normally improve on their products. All these companies that make cars. So you say, oh, this is Honda, so they will make another advanced one. These are the things that they actually improve on. So they want to improve on the lifespan. Sometimes they want to improve. They use the MTTF of the last version to actually what create what the new version. If the last version normally lasts for 20 hours, we want to ensure that what our client will be able to enjoy the next one more than what 20 hours, might be 25 hours, so that they will find the new product better than what the old products. So this is what actually govern maintenance, okay? The scheduling of maintenance across what the industry. If you understand these that I've done, please give me a thumbs up. I really want to have your thumbs up if you understand everything I've discussed in this area. All right, thank you so much. Thank you. Let's switch to our, yes. Thank you so much. Thank you. That's great. Thank you. So we are moving on. So this is what we discussed, the extent to which we discuss. Yes, there are so many things for us to discuss. I've run through the types of maintenance. I've run through that. And yesterday also we discussed the benefit of effective record keeping already. So we discussed best practices for record keeping, where I was talking about CMMS. That it is a software that makes you to automatically schedule the maintenance, and you'll be able to actually attach the name of the personnel that would be in charge of that maintenance. So let's move on by now discussing a lubrication system. So briefly, I mentioned it yesterday, but we just want to elaborately look at what lubrication system of maintenance or in machinery actually entails, because it's part of the things that you touch when it comes to maintenance. The first thing you need to understand about lubrication system is that we use it to actually reduce frictions in machinery. And talking about friction, because I believe that we have a lot of people that are engineering oriented among us. So friction happens when, a metallic surface, let me use a metallic surface, because that's what is not, it doesn't necessarily not to be a metal, but because we are dealing with machines. So you can see when you take two metals and you rub them together, what will happen is that there will be a restriction in their movement. So imagine you take two spoons in your kitchen, you are trying to rub them on each other. Notice that effect. Now that same two spoons, get even a palm oil, or you can get a granite oil, rub it around those two spoons. Now try to rub them on each other again. What do you notice? So you can actually try that out. Try it out if you have not practically seen the effect of friction before. So take two spoons, metallic spoons, rub them on each other, feel the movement, and now put oil around them. Try to rub them on each other and see the movement. You will see that when you apply the oil, they are going to move, much more freely on each other. And that is that's how to actually reduce friction. It is that restriction of movement that we call friction. So when you apply lubricants, they reduces friction. They also prevent corrosion. So if you check, you see that we now use electrolysis to electroplating. How many of us may actually know what I mean? So it's part of the benefit of electrolysis, back then. So electroplating simply means that if you look at some of the spoons that we use now, in those days, I don't know many of us that make those kind of spoons. They were actually made of metal. You see them very heavy. Even before you put food in your spoon, the spoon itself is a load, is stress. Until we now begin to have all these stainless spoons that are actually being electroplated with silver. So they are coated with silver. So all these things, this quotation is to prevent what? Corrosion. So also, if you put oil, you oil what? The metallic or rotating part of a machine very well. It helps them not to corrode. Okay. Lubricant also help to remove what? Heat. Many of us even practically do this. Okay, if you have a burnt, okay, if you sustain a burnt at home, you may quickly get what? Palm oil. You say you are dipping what? That place that is burnt, you want to put it in palm oil. Why? Because you believe that what the palm oil can actually help you to extract what? Heat out of that burnt place. So exactly, so some of these lubricants are also for the purpose of what? Removing heat from a machinery. Because excessive heat will always damage some part of the what? Of the machine. So we want to apply what? Lubricant to remove it. Some of these lubricants are also meant for cleansing. Okay, I explained this in the last class. They can remove a debris. Let's say you have some part that eventually, wears and tears and all that. This oil being in the system can really separate what? Some dirt, okay, from such what? System, and prevent what? Further damages. Okay, and eventually applying what? The lubrication system, making the lubrication system to be intact will also help us to improve what? The efficiency of the machine. What is the efficiency? When you reduce friction, you are going to use a lesser energy. The energy consumption will be what? Lower, because machine won't have to struggle to overcome what? Friction, to overcome the opposition, to overcome the movement that is not what? Smooth. The machine will not struggle to move. The rotating part will not struggle to rotate. So if there is no what? Struggle for them to do all this, you will need a lesser energy to rotate them. And that will also what? Kind of what? Help your power. And you can see what power generation is actually talking right now. You can't really imagine what many production or manufacturing company who have to provide their own electricity. You don't know what they may actually be going through right now, especially in this part of the world. So if there's anything that you need to do, which is, use securing what? The lubrication system of a machine in order to actually what? Use the lesser energy. Of course, why wouldn't you do that as an engineer? So let's move to the cooling system. Sometimes people also look at cooling system as lubrication system, but I've explained the lubricants, some lubricants also, they cool down what? The system. Why they cool down the system? By removing what? The heat. But we have to discuss the cooling system, differently, because cooling system is actually centered on, regulating what? The temperature of the what? Mechanism. So we have to, you may have your fan, you may have a cooling fan, okay, that is actually what? Extracting what? Heat, or blowing out what? Heat from what? The machine, or blowing what? Air, compressed air on the, the part of the machine that may heat up. When you look at your electric motor, you can have what? Overheating, you can have insulation failure if the fan, the cooling fan actually fails. So when it's overheating in a machine, if there's any part that is insulated, the insulation will break down. All those wires that are used to coat your coil inside your stator, your armature, everything will actually what? Burnt. And once you have what? One phase already touching the other phase, what will happen? There will be a problem. There will be we will say there is a short circuit in the machine, and then the machine will have to what? Shut down. So cooling system regulates the temperature, and of course, by regulating the temperature, it will prevent what? Damage, because high temperature or excessive temperature will actually damage what? The part of the what? Machine. And this will also improve what? The performance of the machine, because when the machine is not what? Is not overheated, of course, there is no way a machine will work that some part of it will not generate what? Heat, of course. But what we are saying is that what? The heat that it will generate must be machinery friendly. That will be friendly to that machinery. Of course, as human, we also, our body generates heat. So your body must not generate what too much of heat in such a way that what your internal organs would not be able to what to bear it. So if you as a human being, you understand that. So think about machine also. The machine also definitely when they are moving parts, there is no way, no matter how you work on what reducing the friction, there will still be what some level of heat in the machine, but it has to be what friendly to the machine. Okay, we may also discuss in your maintenance, you must have seen different kind of lubricants being used. There are sometimes what some machine actually make use of what oil, lubrication, and all these things. When you pay attention to most of those machines, there are peculiarity of what machines that use what oil for their lubrication. For example, if you see most of these heavy duty machine like your tractor, okay, like your forklift. So when you see them, you see that most of them make use of what hydraulic as their power source, and anything that is hydraulic is what oil. Oil is actually the one that is generating what power there. So when you look at most of, I show you the example of I show you the picture of tractor, the forklift. I show you the example of all those ones yesterday. The car lift and all that, they use oil because they work on hydraulic, and oil is also what used to actually what lubricate them. When you look at some machines that make use of grease, okay, there are some machines that make use of grease for their own lubrication. So you can use grease if the moving part in that machine, or the part that is supposed to lubricate, if it's not easily accessible, it's not something that you can be accessing from time to time, you may have to actually use what grease, to actually what grease that part, since it is a place in the machine that what you cannot be going there frequently for you to actually what lubricate. So there are some machines, this will actually sound funny, hardly will you see a machine that use water as lubricant, but we also consider in maintenance, we consider water to be what a lubricant, because definitely what lubricant does is to, part of the work that lubricant does is to remove heat. Water can also remove it, especially in human body. Our own lubricant. Many of us don't know that what human body also have what lubricant, and our lubricant is the water in the body. That's what is lubricating your elbows. If you have seen the anatomy of human being before, the skeleton of human being, you see the body of human being is made of what bones that rotate on another bone. So when you look at all these joints, your spinal cord, your tissues, water is the lubricant that you are making use of. We also have some machines that make use of what gas lubrication. When you're talking about pneumatic powered machines, anything pneumatic, when you hear the word pneumatic, it is air. And when you hear the word hydraulic, it is what oil. So the pneumatic, there's some machines that use what gas as their own what lubricant. We have some cooling system also. I've mentioned the one of what air cooling system. We have the water cooling system. We have some that also make use of oil to cool down. We have evaporative cooling, and the last one is what heat exchangers. Of course, if you know the working principle of your air conditioner, and your fridge and your freezer, these actually make use of what heat exchangers. Your AC in your room, you will feel cool inside the room. But what happened? So the AC is just extracting the heat in the room, and then that heat is being what evaporated out. That's why when you go to your radiator outside, you see that what it will be hot outside, and inside will be what cool. It's just extracting the heat. What is that particular coolant? What is that coolant inside it? It is what gas. So when the heat inside the house heat up the gas will what expand. And then when it goes through what the circulation, it will what reach what the aspect of the fan. The fan will extract it. That's your radiator fan. We extract it out. Those heat will escape through the what radiator, and then the gas will go again, get heated up again. The heat will be what? It will be extracted out. The gas will circulate again, get heated up again. Why is it becoming heated up? Your breath inside the room, the little heat that is inside the room, until the temperature of the room actually drop. And then you say that what? It is cool inside and hot what? Outside. So what is the best practice when you are dealing with lubrication and cooling system of a machine? It's very important, especially I'm already talking about the mechanical aspect of what maintenance now. So what is the best practice? The best practice is regular maintenance. That's preventive work maintenance. There is no maintenance that supersedes preventive maintenance. And this is the problem of industry. I discuss with, the problem we have is people's orientation. Most of the problem and the downtime across industries are human caused problem. Why? Because of the attitude of people towards maintenance. The first is attitude of people towards the work. Many people don't like the work that they are doing. And when you do not love your job, there will be every tendency for you to actually your integrity will be dangling. A lot of people are like that. Most of the factory workers, perhaps most of them are not really happy with the job. And this is part of the advice we normally give most of these factory managers. People should not be overused. There are some companies that use the same staff they are using for operation for maintenance. That's practically wrong in the industrial setting. The people that will be in charge of maintenance should be in charge of maintenance. And people, yes, I explained yesterday that there are some level of maintenance that the operator of the machines, the operation guys can do on the machines. But this is different from the preventive maintenance. Some operators of machines, they can actually repair their machines. I know many people that they become their own car mechanic, and they never learned any mechanic work anywhere. It's just based on their experience in driving a car. So once the fault happens, they are already conversant with what could have gone wrong. So even when they are calling the mechanic, they are telling him what to do. So you cannot come and do that kind of people. They understand the machines that they are using. That is, they understand the car that they drive. So there's an operator like that they do not learn how to repair the machine, but because they have been operating it for a while, they know how to bring it up when it actually goes down. So in the case like this, an operator or the guy in charge of operation can actually help when it comes to corrective maintenance. It may help. When it also comes to condition-based maintenance, an operator can actually do that. You are the one running the machine, and then you observe that physically observing the machine, you see that this machine is not right. Something is wrong somewhere. Even though the machine is still forcing itself to work, it seems like everything is okay. You can look at it and say, something is wrong somewhere. And then you want to actually shut the machine down. You call the necessary authority, you inform them that please, I have to shut this machine down and quickly do this. They give you go ahead. You can do it. But the preventive maintenance is for especially trained people. That's what I'm saying. And that's the regular maintenance. Regular inspection, regular lubrication, regular improvement on the cooling system or monitoring the cooling system. It is very, very important. That's the best practice, for lubrication. Another thing is that when dealing with lubricants and cooling system, you have to be careful when you are selecting the lubricant itself. Many of us don't know that the best lubricant to use in Toyotas is for you to actually buy there are specifically recommended lubricant every manufacturer. It was the day I used I bought I went to a mechanic workshop, and they just told me that they have to change this oil. And meanwhile, it was an emergency breakdown of my car that made me to go there. He's not really the one that normally work on my car. So when I got to the actual workshop where they normally maintain my car, and I told them that they changed the oil, the guy in charge of my car was very, very angry. Then why didn't I call him? He could have come from those or speak with them before they changed the oil. In fact, I was so shocked. Because I actually bought a very good product. But he said yes, it's a good product, but it's not the one that is recommended for my car. So a lubricant might be good, but is it the one that the manufacturer actually recommend for that machine? So you need to check the manual and be sure that the lubricant that you have chosen. Many companies don't do this. They just say, oh, that's what we use, and then they begin to put the, and the repercussion is that it will definitely affect the lifespan of the machine, whether you like it or not. This person must be eating rice. You said because beans is sweet, or you go to hospital, they said you should not eat this kind of food again. The doctor said based on your health, you should not eat this kind of food again. It does not necessarily mean that the kind of food they ask you not to eat, they are bad. No, they are not just good for your health. Other people will be eating it and it will be nutritious to their own body. But for you, it has become something almost like a taboo or poison in your own body. So you should avoid it. So that they said that you should not eat beans again does not mean that beans is bad. Beans is actually good in its own. So some lubricants, it's not that they are really bad, even though there are some that they are actually they are fake of lubricant. I know somebody that is into oil, not this lubricating oil business, and he told me so many things about how people actually make the fake of all these lubricants. They make the fake of most of these lubricants are very, very common out there. And they will even label it like a known product. So if you care so much about the maintenance, you have to be really careful when you are selecting your lubricating oil. Okay. So proper selection is important. Monitoring is important. Be sure that there's no contamination on the oil. That's another thing. There should not be contamination. If little amount of dust should actually pour inside the lubricating oil, trust me, it can cause problem in the machinery system when you pour it in. If there's a little amount of water that mix with it and you still pour it like that, trust me, it will have a negative effect on the machine. So it is very important. Not everybody can also lubricate machine. People should actually be trained. It is a simple thing, but you have to be trained. Like why I'm saying that you need to be trained is that it takes people who have actually, let me show you something. Let me relate something with you quickly. It takes only people who have been doing this to actually know the repercussion and to adhere into the instruction of the manufacturer. Many of us have seen, if you have seen this in some mechanism before, you let me know. I want to draw something. So if this is where you need to actually put the lubricating oil, okay, when you watch very well, the container can be as much as this. You will see low. In fact, in your car, if you check your engine, that's where we have the gauge. Okay, if you check the engine oil level, you will see that even that gauge that you are using is actually being marked. You see the mark here, you see the mark here. That is this is the lowest level that your oil should be, and this is highest level. Because you have money, I say I have money now, why should it be there? And then you pour the oil, until you reach this level. You want to kill that machine. That's what you are going to do to that machine. So it's just like overfeeding a child. Okay, this is the amount of food that this child should eat. You said because you are a rich father, and then you want to show that you're a rich father. You said instead of taking 1, take 3. That's an overdose for that child. Or the doctor said that we should take 2 paracetamol. You said that the headache is too much, and then you carry 6. You use 6. So just look at how you are going to feel in your body. Then now translate it to machine also. The oil level, you have to check the level it must be in the mechanism. So they always mark it. Check it very well. Any machinery that you see where you have to put the oil, there are always guideline on the level of the oil. The container don't be Don't be deceived by the container that, oh, it's very big, it can overflow. That's not what they are saying. Because why you have to put this level is that what? When the oil is actually heated up, it will still expand. The viscosity will reduce, it will expand. So the allowance has been given. This allowance that you are seeing up here has been given for the expansion to occur. So imagine that when you fill it here, what will happen if the oil is actually what heated up? There will be spillage, and this spillage, I've heard of somebody before that oil actually spilled and entered the dashboard of his car, enter everywhere in his car. That might not actually be because of the what, the too much of oil, but that it must actually what be something. The oil mechanism in the car, either it is not well tightened, either it overflow or anything whatsoever. So you must always check the level, and that is why I was explaining that what the personnel that will do this must be trained. You can't just say anybody can just carry, just go and gauge the oil of that machine or of that car. You know, you can kill that one particular machine. It is somebody that is experienced that can feed a baby. So just see it that way. So people must be trained to actually want to do that. So you monitor and then you train the personnel. So what are the consequences of poor lubrication and cooling? Equipment failure. There will be equipment failure. Of course, that one is guaranteed because there will be wears and tears. Too much of heat in the system will make what? Some part of the what? Machines to damage, and it will definitely what? Break down. The efficiency of the machine will reduce. There will be wears and tears. And most importantly, there will be risk to your health as a person. Even there will be what? A negative impact on the what? Environment where you work. So all these things are very, very important. There are some parts of the machine that if you do not actually want to maintain them, instead of the noise level to actually be low, and the machine is not making too much of noise, whose ears will it affect? It will affect your ears because there are some operators that stand with their machine, you know, 95% of the time they will use in the factory to work on that day. They cannot leave that machine because they have to be on observation, even when they have already set the machine to work. So imagine that what you stay with your machine, let's say you are even working 7 to 7. There are some shifts that are 7 to 7 work. Okay, that's like saying 12 hours. You are using 12 hours to actually work. So if you use your 12 hours to listen to what a higher what noise that is higher than what the level of decibel that should actually what enter into your ears, and you do that every day, you can imagine the damage that will actually cause to your safety. So it is very important for us to look at this. Now, the next thing we want to look at in our industrial maintenance, machinery maintenance, is for us to have an overview of some tools. You know, some tools that you will need for your maintenance. It is very important. Anybody here who normally perform maintenance on machine? Do we have people here that perform maintenance on machines? Please signify. If you know that you have performed maintenance on a particular machine before, signify. Anybody? Anybody? Any maintenance engineer here? The machine that you use, those people that spoke to me in the last class, you don't perform maintenance on your machines? Okay, is there any engineer in the house? I'm going to call people myself. Okay, is there any engineer in the house?
Yes, sir.
Okay.
Abdullah, yeah. Okay. I think you will drop the line now.
Engineer Abdullah, is that Abdullah? Who said yes, sir?
Engineer Daniel, sir.
Okay. Thank you so much. So you perform maintenance. Tell me some tools that you use during your maintenance. What are some tools that you normally go with when you want to go and perform maintenance on a machine? Are you there?
Yes, sir.
Tell me some of the tools that you normally use for your maintenance.
We use spanners, set of spanners, set of screwdriver with mallet hammer,
Or you are not in the
Sorry,
mood?
can you hear me?
Can you hear me?
Are you
Engineer,
with us?
okay, all right. Yeah, we can use stethoscope for testing for
What's the nature of your work?
electrical engineer, mechanical engineer.
Mechanical engineer?
Electrical engineer.
Okay. So what do you use in your own maintenance? What are the tools that you use?
I use stethoscope for testing for noise level of motors. I also use infrared cameras for testing for temperature of motors.
Good. I love that. Thank you. I love that infrared that you even mentioned. I love it the more. So, any other person?
Yes, sir. Can you hear me, sir? Hello, sir. Hello. Hello. Can you?
Please go ahead.
Is that Felix Okon? Felix Okon, you can unmute your mic. Mr. Felix?
Yeah. Good morning. Can you hear me?
Yes, please go ahead.
Yeah. The maintenance I perform is what we call autonomous maintenance. That's a maintenance carried out by operators on the line. For instance, clicks. It's what we call clicks. Cleaning, clean your machine, lubricate some moving parts of the machine, inspect, and also tightening using a spanner, depending on the size, either 14, 12, 8, or the case may be. And because my machine is associated with some vibration, so over time the bolts and nuts will get loose, which will need for me to use a spanner to tighten. So those are some simple maintenance that I carried out on my machine. Thank you.
Okay, thank you very much. Oladele Fatiu, are you leader? Oladele Fatiu. Okay. Dohati Oladele.
Can you hear me, sir?
Yes, please go ahead.
Yeah. For my own end, there, I'm into production mechanical maintenance. And what we actually do is when we go for maintenance, I will first go to the machine to first inspect whatever I'm going to do on it, and look at the board, the fasteners and everything, and look at the sound of the machine to know what to do on it and the spanners to hold. And once I go back to the office, I hold the exact spanners and tools I need to hold, which my set of spanners, set of screwdrivers, mallet hammer and heating hammer. At times I go with racks, lubricate when it comes to oil, lubrication part, so I can clean after the job has been done. So that's it.
Okay, thank you very much.
Jeff Egbai. Jeff, can you hear me?
Mr. Moderator, is our class on record?
Yes, our class is on record.
Okay. Who else?
Jeff, I can see your hand. Can
I go ahead?
Yes.
Yeah, 1 minute. All right. Good evening. Good evening, Mr. Presenter and the moderator. Yeah, I'm into biomedical engineering, and the equipment usually, or the tools, sorry, I usually go around with for my maintenance, the routine maintenance. It's usually my digital multimeter, my Allen keys, and touch screws. Keys, sorry.
Thank you so much. That's detailed. Thank you so much. I appreciate you. So that is exactly what we wanted to do now. We just briefly look at those tools. Of course, they are not things that we should too much on. Can you hear me? Can you hear me? Can we hear me?
Very.
You can go ahead, sir. You are audible.
Okay, thank you so much. So we look at those tools. The first set of tools are your hand tools. You know, these are your hand tools. Wrenches, okay? Some of your wrenches can be adjustable. You can have the socket one. You can have what? The box head. Some people use pliers. I think plier is a very common hand tools during maintenance that we use. And we are talking about all types of your what? Pliers. There are still some engineers that I see, electrical engineers, that use their teeth to peel wires. It shows that what? You are not trained or you are quack. Okay? It means either you are quacked or you are not trained, because it's not a proper practice for you to use your mouth to peel wire. So you need to use your pliers. Okay?
Very clear.
Please mute your line. Who is that?
You can proceed, sir. I think that has been resolved.
All right. So we have wrenches, pliers, screwdrivers. And when I'm talking about your screwdrivers, I mean your flathead and your star screwdriver. There are some people that use the set of what screwdriver. That is better because it makes precision. It gives room for precision when you need what to use it. So hammers. Yes, somebody said most of the time you have to come with pliers and screwdrivers. Yes, they are common tools. So people go with hammers, usually the mechanical guys. I've seen them a lot. Maybe you want to, there are some joints that you need to, the way they do it, they put something like a chisel on that joint part, and they have to use the hammer to hit it so that it will come out from the other end. So use hammer, some use tape measures and levels just to check for their oil level, coolant level and all that. Some make use of the utility knives. If you have seen utility knives before, let me see. I think I have a collection of some pictures. Okay, I was thinking I have those pictures. So you see some set of pliers, screwdrivers, utility knives. Utility knife is for, you can use utility knife for those that normally use their teeth on wires. Utility knife, you can use it to actually peel off the insulator of your wire. There are some wire that you may not be able to use plier on. Okay, maybe because of their thickness or because of their thickness or the kind of conductor that is in them, you may not be able to use pliers. So use your utility knife. Just as if you are sharpening the mouth of an arrow. That's the way. Okay. So you also make use of cutters. Some people think that pliers can do the work of cutters, but in most cases it is not so. So the cutters actually specifically they are meant to actually cut. Okay, pliers are meant to twist, but some people are good. There is a smaller part of the plier that you can use to cut. But if you really want to do the work of cutting during maintenance or installation, then you need your cutters, strippers, socket set rather, the rackets, your power tools. We are talking about drills. We are talking about your grinders. We are talking about your circular saws, rotary hammers. Okay, some specialized tools that you also use, your multimeters. Okay, this is the one of the practical that I'm going to be having a demo with you is on multimeters. Okay, I'm actually pushing that one to be for our class tomorrow, like the hands-on. That one will look like hands-on. It will feel as if you are doing it with me in the class. Multimeter, your oscilloscopes, my friend mentioned the infrared thermometers. Okay, you will see if you have some materials that are being transported on a conveyor belt or that will flow through a conveyor belt to another processing unit. and you really want to monitor their temperature, okay, you can use all these infrared thermometer. There are some that are handheld that you just come and will use on it. But there is one that is called pyrometer. I think I'm correct, pyrometer. So that one is actually attached. So at distance, from distance, it can actually take the reading of the temperature. So for leakages, you can use ultrasonic leak detectors and vibration analyzer to actually measure the vibration level, pressure gauges are there, and all this. So we have all these equipment. The other aspect of maintenance that we need to discuss is the safety aspect. And in most cases, this is actually underrated. Even many guys that are good in maintenance, they overlook these aspects. And I can tell you that I've seen a whole lot of people. In fact, the only thing is that I can testify that I also have a direct experience. But my own direct experience is not like that of some of my colleagues back then in industry. Who actually God actually saved them, narrowly. They could have actually passed away just because they wanted to perform maintenance. And these are the things that you should pay attention to. The safety aspect of maintenance is very important. When you're going for your maintenance, okay, let me make people to contribute on this. What do you actually want? What are the things that you do as the safety aspect of your maintenance when you're going for your maintenance? That my friend that mentioned the electric motor maintenance. Is it Daniel? Engineer Daniel? Are you there?
Daniel.
Okay. So what do you do in the aspect of your safety when going for your maintenance? Are they there with us? Okay, I think I should not know. What are the things you put in place for safety when you are going for your maintenance?
Yes, it's anonymous. I'm informed.
It's just there.
All right. I should go through Engineer Daniel one part. I think
I think we are using through other device on you.
Okay. So usually what the important thing to discuss is supply. If you're using power supply the equipment in the machine, you should be able to start so that the management is on so that nobody goes into power the machine while we are running the maintenance on it. So you come. Number two, we should also do well to clear the workspace of the area.
Okay.
For any hazardous, there's a material.
All right. Thank you for your contribution. Okay. So I think you can
accidents, hospital industrial accident.
Okay. Thank you for your contribution. I really appreciate it. Thank you so much. Abdul Karim, you still have a contribution? Okay. So these are the materials, your PPE, okay, that you should actually put in place when going for, depending on the kind of maintenance that you are doing or the machinery that you actually want to maintain. Your hard hats and safety glasses, okay, your ear plugs and ear mops, depending on the level of noise, okay, the level of noise, you use your earplug, you use your earmuff. Your respirators or your dust mask. I remember back then we used what the dust mask. That's what we do because I work in a cement factory. Your safety boots. Okay, if you know that the illumination level of where you are working is low, you have to wear your high visibility vest that we call or reflective jacket. In other words, if you are working at height, then if your maintenance is being performed at height, your safety harness, okay, you must actually use it. Your first aid kits when you are working on your maintenance, make sure that you have first aid kits, close by in case anybody sustain minor injury, cut, and all that. Fire extinguishers in case of a fire outbreak, fall protection, your harnesses. I've actually made mention of that. So all these are very important. I'm still going to talk so much about the safety aspect. So what is the guideline? Every maintenance engineer must learn about safety. It is very important, and they must be ready to follow it. They must know the right PPE to use, and they must know how to use them. In our safety training, we train people on how to rightly use their PPE. It is very important. It is wrong for you to wear your helmet, you are wearing your helmet backwards or you wear it sideways. Helmet should actually be worn in a way that it will protect your head and not just to beautify your head. So it does not matter how you look in your helmet, but what matters is how safe your head is inside your helmet. Likewise, your safety boots. Your Timberland is not a safety boot. That you have a very big shoe that look bogus. It does not represent a safety boot, because a safety boot is protected. It has it is laced with metal to protect your toes from fall and to protect your foot from anything that can puncture you when you step on it. So it is important that in the maintenance environment, thank you for that contribution. It has to be cleared. You have to tidy up. If there are iron filings and all that, you have to pack them properly, because anybody can step their foot on it. So I have all these, your head protection, either bomb caps. If you go to some food processing company, you will see that the kind of ones that they wear is they are like air nets. That's to protect the integrity of the product, so that there won't be contamination in the process of making it. So all these are very important. So we have it covered. Of course, like we promised, you are going to have this material. So we have it covered. So that will make me to talk about the major aspects when performing the maintenance, which affect the safety and which is part of this process, and that is LOTO. And that's what our contributor, the engineer that just spoke, actually contributed on. That they will actually follow the LOTO process or the procedures, so that there will be the safety of the maintenance guy will be guaranteed. Now, what is LOTO itself? So we use LOTO to actually secure the lives of the maintenance team in such a way that there will not be accidental startup of a machine when they are working on it. We use LOTO to prevent a machine being accidentally started while people are working on it. Okay, so let me do some analysis. Let me share my whiteboard. Let me do some analysis. I hope you can see this. I hope you can see my whiteboard, right?
Yes, yes. Yes, it's your whiteboard.
Okay. Lock out, tag out. Now, in most industries, when you want to work on a machine, you already know that this machine, is being powered up. is using electrical power. It is wrong for you to perform maintenance on a live machine. A live machine means that what this machine is still being powered up. So this is a live machine. So that what do we do? You have to go to the electrical department, or I don't know the procedure in your own company, but in the company where I work, they will come to us in the electrical department and they will tell us that what they want to perform maintenance. As an electrical person that is also in charge of this, you dare not go and shut down that machine. You have to first confirm. Is it the preventive maintenance they want to do on the machine, or the machine actually ran to failure, or the machine actually fail on its own, I mean. So if it's preventive maintenance, you must have known if they are using CMMS, electrical guys, they will have access to this CMMS for them to check that it is true, this machine is due for maintenance. You see the advantage of electronic schedule maintenance. So electrical can actually see it, and what electrical will give you, they will give you a form to actually fill. So in this form, when you fill it, there will be duplicates, just like your bank teller. So there will be duplicates, and this duplicate means that a copy will be given to you. So you hold it as an evidence. This evidence is against the electrical. I actually came to you to collect line clearance. We call it line clearance. So you, as the personnel that want to go and work on the maintenance, you need to hold this paper. A copy will be with you. In this paper, what would they write there? The machine you want to go and maintain, your own name, the name of your department where you are from, and the duration you will use on the maintenance. It is very important. You can't do maintenance forever. If it's 1 hour, it must be specified. If it's 2 hours, it must be specified, so that you know how long you have to work on maintaining that machine. It is very important. So it will be specified. The time you are going to use on the machine will be specified. And then you hold your own copy of the paper. So the other copy, okay, there will also be a duplicate that will remain. You know, it's just like a bank teller, the way you tear it out, or the way you give people invoice, okay, or you give people receipt, and then you are keeping some duplicate with you that is an evidence. So the electrical guy will follow you to the machine, and it is compulsory. I don't know the procedure, but the practice and the standard is that do not collect that paper and go and start your job. No. Follow him to the breaker or the circuit breaker of that machine. So in your presence, they are going to power this off. This is the power source. They will power it off. When they power it off, they will put this tag, the copy that is bringing, this copy, they will put it on it. This tag shows that men at work, or so electrical guys at work from so time to so time. So the paper is there, so that anybody that comes to this breaker, they will see this paper there, that people are working on it. Now, what happens? What if we have a crazy person that is impatient to read what is in this paper, and the person now open the breaker and just power up, and you are on the field working? That is why we now have this paper is the tag out aspect. The paper means that you tag it out. The paper that you put there is the tagging out. The lockout now says that even after you have put the paper, you need to secure this breaker with a padlock. Put a padlock there, lock it up in such a way that anybody that comes there, even though it's crazy enough to remove this paper, of course, when it's about to open the breaker door, you will see that it has been locked. And they will give you the key. That's the wrong aspect I see, the wrong practice I see in some industry. The electrical guy will not go back with the key. No. You that want to work on the field, you have to actually go with the key. You keep the key and you bring it back to electrical when you are done. So that when the key is with you, you are guaranteed and you are sure that nobody can start that equipment. Now, another thing, if you have that benefit in your company, also use this that I want to talk to you about. Now, when you go to the field, you will see the push button to start machine. This is usually big. So this is actually what the green one, which is to start. This is what the stop, and this what is the emergency. If your company is fully automated like the one I've worked with, you know, most of the companies where I've worked, they are fully automated. It means that what they do not have to come to this what, to this push button. They don't have to come there. Somebody just sit down there in the control room. They sit in the control room and power up what? This machine. You know, distance starts. They will start it from a distance. So what happens when you come for maintenance? As an electrical person or as a mechanical person or whoever, as a maintenance, even after you have taken what the line clearance, they have padlocked it, they have done everything. Please, when you come to the field, make sure you activate this emergency what switch or this emergency button. You know the use of this emergency button, it means that even if they want to power it up at the control room, the machine will not start. This actually cut off what electrical supply to this machine. It's an emergency what button. But the only fault that many maintenance guys normally have across industry is that when they are not done with the maintenance, many of them will forget to release this emergency button. And it will eventually lead to downtime. Because by the time you did not release this what emergency switch, and the control guy in the control room is not ready to start, they will have programmed it that what this machine will start by what? Maybe 8 p.m. Imagine you want to start by 8 p.m., you will be seeing the error. Error will be beeping on its own system, showing that what there is an emergency switch already activated on this machine. The time that you will use when they call what your department, please, so the machine that you maintain, you forgot to actually what release the what emergency switch. The time you will use to run from your office, because in most cases, especially if you work in a large what factory, I work in large factory, where it will be if you are going from one line to another line, it's as if you are traveling, even within the factory. Especially if you do not have what operation vehicle. The time you will use from your department to go and release this emergency switch, trust me, you have used 10 minutes. That 10 minutes will be recorded to your department as that time. You are the one that caused that time. And you know the millions that what you have lost. So, but all this actually help you. If you activate the emergency switch, remember to actually what release it in case when you are done. So these are actually what Lotto actually works. So you log out, you tag out. You must tag out, and then you must also lock it. And then personnel must be trained. They must be trained on how to carry out. Okay, the personnel must be trained on how to carry out what Lotto across what industry. It's very, very important. Let me share this now. If you understand what Lotto is now, please, you can give me a thumbs up. Give me thumbs up if you understand what it is now. Good. Good. So you have been doing it wrongly, please make sure that what you care so much about your own life, and then you go and correct it. So thank you so much. I love the thumbs you are giving me. So that is what Lotto. I don't want us to have actually what broken it down, and then you have this. So I explained this also yesterday, that every machine, on every machine, there must be hazard what identification. So you must actually what identify the hazard attached to a machine so that you know the level of risk. You know, when it comes to working on that machine, what is the level of what risk? Now, in calculating what the risk aspect of a machine, you have to what assess what is the probability that what the harm from that machine will occur, and if the harm from that machine occur, what will be the severity? Let me give you an example. Okay, I will use one person to assist me with this. One person that wants to volunteer. Don't worry, you are not doing anything for me. It's just like you are just backing up. Anybody that wants to signify? to be my partner on that. Mr. Moderator,
I can
have hands up.
Adekunle, are you willing to support to help the trainer in this aspect?
Yes, sir.
Okay. Thank you so much. Thank you so much. So let's say we have a machine. And just what we want to discuss is for us to know what we talk about, what risk assessment. Okay, very briefly. We don't need to waste time on it. I just want to give us a brief illustration about it. So this is a machine, and then we perform hazard identification on it. We see that what this part of the machine can cut somebody, and this part of the machine can also cut somebody. Let's say part 1, part 2. Okay, the part 1 and part 2 can cut. Okay, so this is what we now do. That I'm saying, we are going to know what is the probability. Many of us, in our math, we do probability. What is the likelihood? We know that what this thing can cut somebody, but what is the likelihood? What is the percentage assurance that what it will eventually cut that person? And now, if it caught the person, what will be the severity? How severe will it be?
Okay.
Are you with me? Yes, so we rate probability from in percentage, or we can say from 0 to 1. Okay, 0 point something to 1. Let's just say percentage. Let's say the percentage that was this one is a cut. Both of them they are cut. The harm that they can cause is of cut. Okay, this one is 60%. This one is actually what? Just 20%. This cut can also happen, but this one, 60%, we know that what if you cut the person that is operating the machine, this 20% that you cut the person. Now, if it cut the person, how deep will it be? That is the severity. I'll be asking my partner now. Can a knife cut somebody? My partner, can a knife cut somebody?
Yes, sir. You can.
Okay, knife cut.
You can, sir.
Okay, knife cut. Can a sword cut somebody? Sword or war?
Yes. Yes.
Okay. Yes, if they give you, none is good. If they give you a tight option, which of the cuts will you rather go for?
I would prefer to go for knife cut.
Why? Why?
Because the severity of the knife is
God bless you.
will not be as much as that of
the severity. Yes. If the cut happens, which one will be worse? Okay. A blade can cut somebody, but when blade cuts somebody, it is different from when knife cuts somebody. It is when knife cuts somebody, it's different from when cutlass cuts the person. When cutlass cut, it's different from when sword actually was cut. So you must talk about the severity. And we use the word low, either low, or we use what? Medium or high. Let's say in this case now, we say that what? It should be what? High. So in this place, it really shows that what the probability is high, right? But when it will eventually what happen, it will be low. In this case now, you can say, let the person wear what? A PPE. Maybe you should use what? Hand glove. Are you getting my point? So we use probability risk assessment to pick what will be our solution on the machine. Can we work with the machine, or we just have to write off this machine? It is the risk assessment that will show us that. If the probability is what? Is high, but the severity is what? Is low. We can tell the personnel to actually what? Wear PPE. Is that not so? we know that what it will just be little cut. And if you wear your hand glove, definitely it will not actually what pierce into your skin. That one is noted, right? But look at this one, 20%. 20% is still considerably what high. But when it happens, let's say this kind of high, the severity is that what it may chop off the hand of the person. Wherever the contact of the person, whatever the body of the person that make contact with the machine at that time, it will actually what cut it off. You see the severity. That is high. And that's what we'll now be talking about what? Hazard control. So the risk will actually will let us to know that what, okay, fine, which of the hazard control should we actually what apply? And hazard control looks like what? A cone. Okay? You travel down to narrow down. The first one is what? Elimination. The next one is substitution. Okay? Can we actually what? Eliminate? Can we substitute? The next one is engineering control. Okay? If we cannot do that, can we use administrative measure? Administrative measure. Or can we just use our PPE? So depending on what you actually have on ground, there are some level of what hazards that when you do their risk assessment, so you cannot go ahead. So that kind of machine may be very dangerous to the what? To the work environment. And then we have to what? Eliminate. So we check the hazard if we can what? Eliminate it. Elimination means that what? Can we avoid it? That part that is so dangerous, is there any way we can eliminate it? In most cases, it is what? It is, almost not practicable to eliminate hazards. Or to eliminate all hazards. It is almost what? Not practicable for you to be able to eliminate all hazards when it comes to a machine. There will still be what? Hazard. But one thing that if the risk assessment is showing us that what? The severity is high, the probability is high, then we have to substitute that machine. Substitution means that what? We have to find another machine, another type of machine to use. And I told you of a company where I work, when they have to change all their generators, they have a reason for it. It may be economical reason, okay? Because it's also hazardous to us to be spending too much, to be wasting power. Perhaps maybe the machine we are using before always, have a lot of rotating parts. They always generate high watt friction, and is consuming what? Lubricant and all that. And then we have to find another machine that can consume less. That is substitution. We substitute it. Engineering control is that what? If the heat is the one that is too much in the machine, can we get some cooling fan? I've seen in some industry, even though it's not the right practice, some electric motor that they have run them for a very long time, and now they are now overheating. You will not see them. Some of us here that have seen such before, they will just be laughing underneath. They will not carry all this aux fan. They will go and power aux fan and center it. This is not in the manufacturer it's not in the specification of the manufacturer. But because they still need that electric motor in that session, and they are not ready to shut it down or replace it, they will not carry aux fan. So that it will be blowing it, to reduce what? The heat level. It's part of engineering control. The cooling fan is part of engineering control. If you see a rotating part that maybe is exposed, you can build a guard around it to cover it, such that the hand of the operator will not be trapped inside. That's still what engineering control. Administrative control is by you implementing some policies. Like we are mentioning about Lotto. Lotto is a policy. Company are so strict with it. Wearing of your PPE is a policy. There are some companies that you will face disciplinary committee if you are being snapped. They will snap you. The safety personnel walk around in the factory. So when they see you in a dangerous place without your helmet, where you're supposed to use helmet, they will just take your picture. And when they invite you to a disciplinary committee panel, they will just show you your picture. What are you doing in this session without your helmet? And if you are being called more than once, it's possible that you are sacked based on that. That's an administrative work measure. Administrative just mean about what? The rules and regulation of the company in order to reduce what? Risk or the hazard. Or you interacting with the hazard in the factory. So it's just for you to adhere with the safety. It goes beyond that. And if we now see that we have tried this one, the last result is your PPE after we have tried the rest. So maybe you should wear something that will protect you so that you will be safe. Let me stop there tonight. I think I've covered much. So tomorrow I will move briefly to just Tim mentioned more of the mechanical. Okay. More of the mechanical, yes. And then we'll talk about the rest. So what I've just explained is about the risk assessment. So I've covered that. And then yes, we have a roll on. So we're talking about electrical safety principles. So tomorrow I'm going to be starting my class with this, talking about the principles of electrical safety when it comes to maintenance, your grounding, your insulation, your circuit protection, dimension logger tag out. I'll be talking about earthing, grounding, the difference between them, your regular maintenance, your electrical safety devices, and all that. So we'll see how far we can go tomorrow. And I really want to actually give you some sample of how questions on industrial maintenance also look like. So we'll test run what we have actually learned so far. If we can actually do that before you do your assessment, let's see some questions that we can answer and all that. So test run. So Mr. Moderator, over to you. I really want to give people room to ask me questions.
Okay, thank you very much, Mr. James Fanny, for that wonderful session so far. Okay, let me bring down my screen. Okay, so quickly, let us take questions on all that has been taught in today's class. Let me lower the hands first. So, okay, now, so if you have your question, please kindly signify by raising up your hands, so we'll be able to take those questions. So quickly, let's do that. Questions. Thank you, Mr. Duarte. Any other person? If you have questions, please kindly drop them. Okay, attention, record. Okay, sorry. Okay, so please, any other person with question? If you are joining us via the YouTube live, so please do well to drop your question in the comment section as well. Any other person? Question? Okay, then, Mr. Duarte, please, can you proceed with your question?
Good morning, sir, from here. Yes, sir. My question is, I was thinking they are going to talk about PLC control, the scenario how to use PLC control to address an issue on a process line, on a process plant. So I was thinking maybe they are going to talk more in depth on it, on a practical level, on how you can use PLC to address a problem on the process line in the production plant. Can you hear me? Hello, sir.
Oh, okay, Mr. Duarte, I captured your question.
Okay.
Thank you very much.
All right, sir.
Do you have any other question? Any other person? Okay, and if you want to drop your questions via the e-message, you can do that as well. Just drop it, type it and drop it, then we'll read it, we'll read out the question. Or if you have any experience you want to share with us and that you need insight, you can as well signify, so I'll call on you. Okay, Mr. James?
Sir. Now for that word, the safety aspect of all engineering was which the facilitator said LOTO. But I think there's what we call LOTOTO also, which is log out, stag out, and try out. The try out aspect, I'm expecting the facilitator to input it so that we can know much about it, sir.
Okay, I'm trying to hear you clearly. You mentioned the aspect of Lotto. Can you
Yes,
recap
yes,
again?
yes. I say from the aspect of Lotto, there is what we
Okay,
call Lotto Totu, Lotto To,
okay,
which I
okay,
have heard about. And that Lotto To simply stands for log out, tag out, and try out. Try out means at the end of you ensuring safety, you try it again. If what you have tagged out and lock out is going to come out again, it's going to energize again, just for you to be sure that okay, there's no issue even when nobody is there, so that you can walk
okay,
safely.
okay, okay. Thank you very much. Thank you for the
So,
contribution. Okay,
okay, sir.
Mr. James, over to you, sir.
Yeah, thank you, Mr. Moderator. Uh, if that's the only question we have, Mr. Duarte, were you the one that asked question on run to failure yesterday?
Yes, sir. Yes, sir.
Was that actually captured in today's class?
I actually came late due to some jobs on the plant.
So it was actually captured. We explained mute time to failure. The only thing that when we are making emphasis on run to failure, we are only making emphasis on some components of the machineries that, let me say, perhaps they are very expensive for you to maintain, or maintaining them is almost impossible. So you can afford to run them until they fail and then you replace. So there are some components like that you run them until they fail. That's what we mean by run to failure. So you run them until they fail because it is more economical. Run to failure focuses more on the cost effectiveness of running a machinery. So if there's any part of it that you can actually run to failure, you can afford to run it to failure, being that when it eventually fails, it will not have a huge impact on the running of the plants. So you can quickly replace them, or you can maybe quickly actually what uh, bring up the plants back into running. So there are some equipment like that. So we run them until they fail rather than maintaining them. It may be cost effective for you to run them until they fail, or perhaps you cannot even carry out a meaningful maintenance on them than for you to run them, they fail, and then you replace it. So that's that if you came late, but that's additional stuff to run to failure. Now, about the PSC that you make mention, don't let us forget that as a trainer, I would like to actually be at the scope of the training. What we are actually dealing with is industrial machinery maintenance. The focus is on the maintenance. Okay, programmable logic control is actually used to achieve automation of a plant. Okay, so and it's really much more advanced than the time we were using transistors and all these diodes and all that. So it's actually a component of a system that we use to achieve the automation of plants, more of the instrumentation aspect of the plant. So although briefly tomorrow in tomorrow's class, I will be mentioning the aspect of a PLC. But what are the major things that they actually do to PLC? One major thing is that they do to PLC. Thank you for thanking me. One thing that they do to PLC is for you to ensure that the programs, that is being loaded to the CPU is working fine. Now, if the output or the input is actually misbehaving, it might be that the programming has corrupted. So major thing that you see them doing most times is that they bring laptop and then they plug into the CPU to check the functionality of the programming. If the programming has corrupted, most of the Nigeria's engineers, they cannot even work properly on the PLC. So the only thing they do is to delete the programs that is there, and then they actually kind of load another program on it. So more of what they actually do. That's one. Two, sometimes there may be some loose contacts at the input and the output units. So you can see that the wires stuff, the input and output wires, they are always much depending on the unit where you are using the CPU. So you have to check if the contact is not firm, There may also be some failure on the PLC. Now I'm talking of the maintenance aspect of what you will see them doing on PLC. Okay. Another thing is that depending on the plant where you are working, where I've actually interacted with PLC in my own company where I've worked, we deal with more of dust. So the product that we're actually producing brings up dust. And when you have dust coverage on anything automation, when you have dust coverage, especially if you are dealing with sensors, proximity sensors, and all this LED stuff, so you have to ensure that the surface are usually cleaned of dust, because that may actually make it to become insensitive. So they bring some blower and set it to a minimal pressure for them to ensure that the contacts are free of dust, rust, and loose connection. So those are the major things you will see them doing on PLC. Although there are trainings under us that deals with PLC, if we're actually going into PLC, programming of it, and automation of the plants. So we have some aspect of our training on that, but in the aspect of maintenance, that's what you will see being addressed. Now about Lototo. Lototo is actually Lotto, but why they incorporated the terms Lototo, okay, just like as you briefly mentioned, is that we have seen sometimes where people or the personnel, they will take line clearance on a particular machine, and then it is not properly being taken care of, and that is why it is being brought into some conscious practice that you should try out the log out and tag out that you have done. So the major thing we are doing in line clearance is Lotto, which is log out and tag out. But because in most cases, many people that are not even trained to take Lotto, they take Lotto. And in the sense that you will see that the breaker that you think that they have actually racked out, okay, is partly energized. And then when the personnel are working on the plant, you'll see that they receive the effect. So the emphasis is being made on, you need to ensure that the Lotto you have taken is properly done. That is why you see some emphasis on Lototo. It is actually Lotto. The other TO that is being added is just for you to test or try out. We call it test out or try out, and that's in the aspect of what we call monitoring and controlling in the management of projects. In every project, the execution, a project should end on you executing it. But for you to ensure that the project you have executed is in line with the expectation or the requirement, then you have to monitor and control. What is monitor and control? When you monitor it and you see that there are some deficiency, then you control it. That is, you effect the necessary change and then you input it into the system. So you have to test out. And for you to know this, if you have worked in company where they use all these big earth breaker, okay, where they use earth breaker, okay, earth circuit breaker, what they do in most cases is that even after they have rack out the breaker, they will hurt it. There's a difference between it's a different thing for you to rack out the breaker. What Lotto will tell you that, oh, rack out the breaker, put the tag on it, but you have to hurt it in case of leakage currents. Because even after you have racked out the breaker, if there's any possibility of leakage current, the person working in the plant can still receive shock. So you have to actually hurt it. So what is the emphasis and the beauty of what you brought up about Lotto? Ensure that personnel that will take Lotto are trained to do so. And aside being trained to do so, personnel that are taking Lotto must also ensure that they properly do it. In most of the standard plants, no, it's not anyhow person that can take Lotto. Mechanical are not to interact with any electrically energized equipment when it comes to Lotto. Different department must not do it except power. That's the electrical department. Even instrumentation cannot do it. Automation cannot do it except power. Okay, and I actually work so well in that particular unit. So why are they insisting that the electrical guys should be the one to do it? Because it is their field. It is not that most time mechanical guys have been following you. They know what you do to the breaker, the way you do it, but that they may not really know the repercussion of doing it properly. So they maintain that only electrical guy must actually do it. The only thing is just that for you to trust him that he's doing it, you will follow him, being that you are the one that will work on that machine. and you have to collect the sample of the tag that you want to put on it, so that you keep it as an evidence that you came from line clearance. In your presence, they must rack out the breaker, they must health it. You must actually what see the copy of the key, the lock. The key is to be given to you. It is only when you are done you bring the key, they can open what the lock before they can put it on. So that's how mainly it's been to be addressed. Thank you so much for your questions and your contribution. Mr. Moderator, over to you.
Thank you very much, Mr. James, for the response to the question.
I didn't hear Mr. Duarte. He tried to talk now, right? His network is.
I said thank you, sir. I said thank you, sir.
All right.
Okay, thank you very much. So it's a wrap for tonight's class. I want to sincerely appreciate everyone for staying up with us up until now. We are 10 minutes, past the usual closing hour. So on that note, I want to say thank you to everyone. Please, we will appreciate your feedbacks. Please kindly put your feedbacks in writing and drop it on the WhatsApp group. Drop your feedbacks there. We'll appreciate it. Let us know what your thoughts, what your experience of today's class is. So just put it in writing and drop it on the WhatsApp platform. If you are yet to subscribe to our YouTube page, endeavor to do so. And most importantly, the information relating to the certification for this course is going to be dropped on the WhatsApp group. So please look out for that information. We'll be dropping it as soon as we end today's class. So the class continues tomorrow, same time. Please, you don't want to miss out on tomorrow's class. That's the third day, which is going to be the final day for this training. So please, try as much as possible to make yourself available in tomorrow's class. And for those who couldn't meet up with today's class, the recorded video is going to be dropped on the WhatsApp group. And if you are already subscribed on our YouTube channel, you will definitely see a pop-up of the class. Just go to the live session, look at the live videos. The latest video is going to be that of today's class. So I want to sincerely appreciate everyone for joining us. Thank you very much. We'll see you again tomorrow. Until then, you have a productive great day ahead. Mr. James, do you have any other thing to add?
Okay, thank you so much, Mr. Moderator. Please, I will emphasize more on your feedback. And I want to encourage you. One of the way that you can connect with this valuable training is you actually going for the certification. This is many years that we've been doing this. If you check this training, you see that it is actually the creative work of the company, and it's actually based on our research. So we send the training materials alongside with your certification. There are 4 certificate categories on this training. So do check the certificate briefing and fill the certificate form. We encourage that you fill the form now, okay, to indicate your the number of certifications that you will take and which one will you take. So once you see the form being dropped, please fill the certification form, okay, so that you can see the deadline and everything that is actually involved. Thank you so much. Thank you for your participation. I'll see you tomorrow. I'm excited to see you tomorrow. Thank you. By God's grace.
Okay, thank you very much, everyone.